ellipses. And so we have the wide kind and we have the tall kind. And negative A, positive A, negative B, positive B. And over here, positive A, positive B, negative B. Okay, so now, and then the equations, x squared over, y squared over, x squared over, y squared over, and what goes on the bottom is whatever's on their direction. Okay, so there we go. So, this will be easier. Notice these formulas have ones on the right. Very different from the parabola ones, which had 4ax or 4ay on the right side. Notice x and y are both squared. There's not a first power letter, is there? They're both squared, and they have things underneath them which tell their dimensions. Let me show you. So I think doing an actual problem will make it easier. So let's take a look at this. Let me redraw it a little bigger for you. Looks like this parabola goes up. Oops. My drawing skills. I told you about my art career ending in 7th grade, right? Mr. Duran gave me a C. And I was trying, too. All right. Trying a little bit, much as a 7th grader tries, I guess. So anyway, it goes up to 5. Looks like down to negative 5, over to 2, back to negative 2. So there we have a parabola. Good, I'm just making it a little bigger. So how would the equation go for that one? So let me help you with that. So basically it's going to be x squared over something plus y squared over something equals 1. How do you know what goes underneath the x? X is right left. Yeah, so remember, so that's the main thing, because we're going to get, we've already had a bunch of formulas, things can get complex. But always remember that right left is always x, up down is always y. That's really the main rule. And so how far right and left? Well, 2 and negative 2. So under x has got to go 2 squared, because that's right left. Under y is up down, so that's 5 squared. There's the formula. So which one is that?
A.
Yeah, looks like A, doesn't it? Good so far?
Because A is going to be bigger than B.
Yeah. So whatever's right left is what goes underneath x. Whatever's up down. Now, I know the A and the B thing can be a little confusing. I'll explain that in a minute. How about let's just don't even worry about the A-B thing right now. Just remember whatever's underneath x is right left. Whatever's underneath y is up down. Call it A, call it B, call it Joe, whatever you want to call it. Whatever's underneath x is right left. Whatever's underneath y is up down. So I just look at that problem, go right left 2, 2 squared under x. Up down 5, 5 squared under y. Done. For now. We'll get to the A-B thing. So number 2, I can draw it a little bigger. Looks like it goes right and left 5. Up and down, what's that, 4? Okay, can you write that equation? It's going to be x squared over something, y squared over something. Okay. So, whatever goes underneath x is right left, because x is always right left. Right left? 5 squared. Y is up down, 4 squared. Done. Whichever one that is. Is it C? C it is. Good so far? So what goes underneath x is right left, y is up down. These are way better, aren't they? They are easier. I mean, they're going to get harder than this, obviously. But they are, I think, quite a bit easier. Because the main thing about them, they don't go 4 different directions. That's what's hard about the parabola. It's really just 2 things, either wider or taller. Whereas the parabolas are going up, down, right, left. They got the focus point inside. They got... Okay, so they want me to, first off, let's graph it. Can we put that on a graph first off? So whatever's underneath x, oh yeah, we should give it the look. It slightly needs a little alteration. 36 is 6 squared, and 9 is 3, right? That's the look, right? You have to write it as a square. Okay, so yeah, then go to the graph. So whatever's underneath X is right, left. So go right, 6, left, 6. Whatever's underneath Y is up, 3, down, 3. Make an ellipse. Good so far? Now they're going to ask us for some stuff. What are they going to want? They're going to want, what are they going to want? Vertices. Okay, everybody good to there? Now, vertices are the farthest endpoints. Vertices are the farthest endpoints. What do I mean? What's the biggest direction on this? This one's wider than it is tall, right? So these are the vertices.
6, 0.
So 6, 0 and minus 6. So they want both. They want those actual coordinates of those points. That's 6, 0. The other one's minus 6, 0. They don't want the top and the bottom 3, negative 3 thing, because those aren't the farthest, are they? Does that make sense? So vertices are always the farthest endpoints, the biggest dimension. You know, by the way, you call that axis the major axis. So in this one, this one is wider than it is tall. So the x-axis is the major for this one, and the y-axis would be called the minor axis on this one. So when they say they want the vertices, they want the endpoints on the bigger axis, the major axis, the farthest endpoints. Okay, next, they're going to ask for the foci points. Foci, which is just plural for focus. There's 2 focus points, the foci. So they want the foci points. Now, let me hold on. I haven't even told you what this ellipse comes from. Remember how I gave you the definition of a parabola? It was the set of all points equidistant from a point in a line. Well, what an ellipse is, if you took a board and you took a straight line and you put a nail and a nail in that board, and you took a string, let me just put a loose string there, connected to those 2 endpoints, those 2 points. If you just took a board, put 2 nails in it and a string tied to those 2 nails, and then you took a marking pen and you said, all right, what I'm going to do is I'm going to put my marking pen against that string, and then I'm going to pull it till the string is tight. So I'm going to pull it, see if I can draw that string. So like that maybe. I don't know if it'd go quite that far. Pull it till it's tight, right? And then I'm going to go down and I'm going to mark holding that string tight all the way. Can you picture what would happen? Kind of mark like that, and it would mark over like that, right? Holding that string tight all the way. And then do the same thing on the other side. That's an ellipse. That's when those 2 points are called the foci points. Those are focus points. They determine the shape of the ellipse. Now, how would you say that in mathematical terms? This is the set, the ellipse is the set of all points that, what?
Makes an ellipse.
Equal distance? So what's equal to what?
Same distance all around.
Yeah, how do you say that in math? What does that mean, same distance all around? So I need something equals something. Yeah, I know what you mean by same.
Is the limit of the string? I don't know how to say it in math, but it's like,
It's an oval.
Yeah.
it's the limit that you can stretch those.
Yeah, think about this for a minute. What if let's do another point over here, and however far the string goes there and there, what do we know? In fact, let me make it a different color.
One's getting shorter, one's getting longer.
Right. And
Stays the same.
yeah, it stays. The 2 purple pieces have to add up to be the same as the 2 orange pieces, because it's the total amount of string. Right? So the set of all points that have the same total distance. It's the total of the 2 distances from the 2 foci. That's what it is, right? This point here, if you add up how far he is from that foci, plus how far he is from that foci. That total, like maybe he's 3 feet from that one and he's 10 feet from that one. I don't know, I'm just making up numbers here. And this other point, maybe he is 6 feet from that one and 7 feet, right? 6 feet there and 7 feet there. See, they have the same total 13? Because it's the whole piece of string. The string is 13 feet long. They have to have the same total distance from the two foci points, don't they? Which is the length of the whole string. That's the dead. Now, you don't have to know that, not required, not going to do anything with that, but that's where it all comes from, just like everything from the parabola. So that's what an ellipse is the set of all points that have the same total distance from two focus points. That's different than a parabola, which was the set of all points that have the same, or have equal distance from the focus point and the line. A little different, huh? That's how these shapes are generated. That's the behind-the-scenes rule that's making it happen. And then things in real life do that, like planets go in elliptical orbits, don't they? Mm-hmm. All right. Anyway, so back to it. So that's what I just mainly want to show you, that's what the focus points are all about. So how do we find the focus? Well, I'm just going to give you an equation. The focus points are always, first off, they're always on the major axis. That makes sense, right? They're going to be on the wider axis, aren't they? Like the two nails on the board. They're not going to be on this axis, are they? Well, if they were, if you put them up and down, then you're going to get one that's taller. So that's my point. I'm not saying that very well. They're always going to be on the major axis. So if the thing is taller, the focus points will be up and down. If the thing is wider, the focus points will be side to side. The focus points will always go on the bigger direction, won't they? Right? Can you imagine if you put the two nails? They would make a shape that's taller. Put the two nails sideways, they would make a shape that's wider. So the focus points are always on the major axis. They're always on the bigger direction. So in this case, this one that we're looking at, number 3 here, is wider. So the two focus points will be on that axis, the x-axis. And how far will they be? We call them C and negative C. They're the same, whatever they are. C and negative C. And here's the equation for finding them. A squared minus B squared is C squared. A squared minus B squared is C squared. Now, why would that be? Why would it be A squared minus B? It's the Pythagorean with a minus.
Is it a right triangle?
Why is it? I'm just kind of thinking it out with you right now. I wonder if I'm going to blow it and use a bunch of time because I'm really winging this right now. I think I can do it, though. I have a thought, but it might be wrong. Let's see. So if this is the center, and I have a couple focus points, back C and over C from this origin, right? And I think if I do this point, which is super convenient, and I do the string up to that point, and remember, this direction is B, this is B, from there to there, and this is A, remember, because this is A, this is over A, back A, this is up B, down B, remember that?
There's two right triangles.
Yeah.
Yeah, is it?
Yeah. We're only focusing on one though.
Yeah, but how do I get the A in there? I'm not sure. Yeah, now I'm struggling. See, I'm wasting our time. So from here to here is C. Okay. So if I do that little triangle, call this call this string or whatever. That's half the string length, huh? Because these two make the whole string length. So B squared plus C squared is half the whole string length squared. So yeah, I'm probably getting too complex, huh? And that's true, right? When you agree with that little Pythagorean thing? Right? Because that's half the whole string, right? Now cast the string out here. Yeah, I think I've got it. Of course, I thought that before. Put it out there now. Do that right. Is that what you meant by two right triangles? That's what I'm thinking too. Now this is A. So A squared plus B squared is, no, okay, but what is that? Oh, that would be the whole string.
Yeah.
Wouldn't it? Because if you put your nail over here, the whole string would have to, wait, I'm getting confused. Is that right? The string, no, it goes from here, and from here the string would go to there and to there, wouldn't it? Oh, I'm just getting confused. Never mind. See, I knew I'd blow our time. Here's the formula for who knows why. Maybe I'll try to come up with it later in my office and then bring it nice and clean. So I thought I could just wing it, but Nope. So, all right, so let's get back. We don't want to waste any more time. So a squared minus b squared is c squared. So that's the formula you always use. It's the Pythagorean with a minus for some reason. And let's now solve for c.
So A is associated.
Yeah, now you got to know about the a and the b and which one. Now I'll bring in the idea about the a and the b and which one's bigger. The a is always the bigger in this formula. That's which I didn't write that. Okay, so a, let me go back here. Did I write that anywhere? A is always bigger than B. A is, in the formula, we just do that for convenience. A is always bigger than B. A is always the bigger direction. So notice, if the thing is wider, I put the A's on the wide. If the shape was taller, I put the A's on the taller, huh? So notice I'm putting the A's on the bigger direction, aren't I? See that? So A plays the role of the bigger one, whichever that may be. If it's wider, then A goes with X, because it's wider. If it's taller, then A goes with Y, because it's more up and down. You with me? So, coming back here, whoops, there's all my failed attempts. Okay, so the A, so which one's the A then? So the two numbers, we have a 6 and a 3. Which one's bigger? 6, and B is 3. So it's 6 squared minus 3 squared is c squared. 36 minus 9 is c squared. 27 is c squared.
Oh, minus. It's not.
Yeah, it's not the normal Pythagorean. It's Pythagorean with a minus. For some reason. All right, c squared is 27. And I also told you I would bring in information about those payday loan places. I'm just
Just don't do it.
yeah, no, I'm interested in both
No,
those
I
things.
mean, don't
Yeah.
get a payday amount.
Yeah, well, yeah, but numbers are helpful rather than just don't. Some numbers are helpful, I think.
They're more convincing.
Yes. All right, anyway, so c squared now, we got to root that, right? And when you put a roof on the house,
Plus or minus.
up and down the ladder. Plus and minus. Remember that rule? So plus or minus root 27. Now, do you remember from algebra how to simplify that root 27?
Plus or minus 3 root 3.
Very
3
good.
times 9.
Yeah, let me show you. So if you break it down, it's 9 times 3, right? 27. Just use your calculator if you're rusty on some of those. So it's 9 times 3.
You throw 1 3 out.
Yeah, and so then you can just square root the 9, square root the 3. Square root of 9 is 3, root 3.
If it's the cube root of 27, then it would just be 3.
Right. We good there? Is everybody good with that? Does that make sense? So the 27 is 9 times 3. You can square root the 9, huh? Just becomes a plain 3. The other 3 has to stay in because you can't root it. But we did root the 9. So you just break it down. If you can root part of it, do that. So it's plus or minus 3 root 3. So where would the focus points be? This would be 3 root 3 up 0. This one is minus 3 root 3 up 0. There's the coordinates. Is that okay? Am I getting a little scribbly there? Let me write that a little neater. So that's 3 root 3, 0. And the other one is minus 3 root 3, 0. There's the two focus points. Questions on that? We good? Finding those? I think that's everything they want. Okay, so try that one. They want you to basically find everything. We can do it quick. These are quick. First off, that one needs a little plastic surgery. He doesn't have the look we need. Why not? What's wrong with the way he looks? Too many wrinkles. What's the problem?
He has a 4 outline.
How about the right side? What's he supposed to have on the right side to have the look we
1.
want?
He says it doesn't equal 1, but he won't say it loud.
That's right, out of money.
Yeah.
Got to make a 1. Got to make a 1 over there. Right, so you with me? So that's going to be for this section, and it's going to be for 10.4 hyperbolas. So you kind of get in the rhythm. It's all about 1 for these next 10.3 and 10.4. You got to get 1 on the right side. So how can I make that 1 on the right side?
Divide everything by 36.
36, 36, 36. Right on through, right? So 4 goes into 36 9 times. So we get x squared over 9, y squared over 36, 1. We good to there? Now we can know, and to make the 9, what is 9?
3 squared.
3 squared, make 36, 6 squared. Now we can go to the graph. Let's go to the graph. Is this one going to be wider or taller? Well, yeah. So whatever's underneath x, am I going too fast? Just looking at the clock, wanting to finish up here. Whatever's underneath x is right left. So don't worry about the taller. I shouldn't have even made you think about that right now. Just focus on x is right left, y is up down. It'll all come out good. Just remember, x is right left, y is up down. So whatever's underneath x, 3, that would mean right 3, left 3. And whatever's underneath y, the 6, that's up down. Up 6. Down 6. We good? So it's taller.
It's supposed to be like this. I just made my.
Last thing. Oh, vertices. They want the vertices. What are the vertices? So is it going to be the top and the bottom or the right and the left?
No, top and bottom.
Yeah, the longer direction, huh? So what's the coordinates of that point at the top?
0, 6.
0, 6. And 0, minus 6. So they want you to say 0, 6, comma 0, minus 6. Finally, the foci. How do we find the foci? Where are the foci first off? Are they up, down, or right, left?
A is the bigger one.
They're on the major axis. So they're always on this. They're going to be up and down somewhere, aren't they? Going to be on the y-axis, aren't they? So for the vertices, we use the Pythagorean with a minus. So the A's got to be the bigger. And that makes sense when you subtract. The bigger one's got to come first, huh? So the A's the bigger. That's going to be 6 squared minus 3 squared is c squared. That's the same thing as we did a minute ago, wasn't it?
That's exactly going to be the same answer.
Yeah, so it's going to be root 27. So the foci points are, this is over 0 up 3 root 3, over 0 down 3 root 3. And we're out of time. We're actually 36.